Good morning, ladies and gentlemen. Those of you that were on your bus trip yesterday, I hope that went well for you, and you got to see some cool businesses and give you some good ideas. I will be checking in the homework that was due yesterday, which was 2 to 8 even. I'll be checking that in tomorrow. As well as obviously this notes that we'll be going over today. Now, you can see that these notes look pretty much identical, the beginning part, to the notes that you had on Tuesday. So recall, what is a system of linear equations? So if it's a linear equation, it is two or more equations. Now, folks, if they're just equations, that means they're just lines that are going to cross. And where they cross, that's my answer, okay? If it's an inequality, that is two or more inequalities. Now, inequalities have greater than symbols and less than symbols. So on a graph, we could have a solid line and a dashed line. And the answer is not where they cross, it's where their shading overlaps. So maybe we would shade below this line and above this line, which means my answer, that was really terrible shading. Let me fix that here. Okay, maybe we would shade below this line and above this line. So then the answer would be the overlap of that shading. And in this case, it would be here. Okay, so that's the difference between equations and inequalities. We talked about linear programming. Linear programming is an application of systems to find a max or a min. It's an application. And so far, we haven't really done the application yet. We've just been doing regular problems. Eventually, we'll be doing these will be whole word problems, and we'll be using this linear programming to find the max and the min. For example, a business might want to find the maximum amount of profit it could make. Okay, so it would use something like this. We have this thing called the objective function. The objective function is normally z equals. Okay, and the objective is to maximize or minimize the value. And on Tuesday, when we talked about this, you were finding the corners of your figure, and you were plugging them into the objective function, because the objective function has an x and a y in it, so we'll be plugging those values in. So today, you'll see I have 3 more examples for you, so we're going to take another crack at these. Okay, notice your directions tell you that you're supposed to graph it. They also tell you to find the objective value or the objective function at each corner and determine the max and the min. So first and foremost, you will see here that we are limited to quadrant 1. Okay, and we talked about that on Tuesday. Quadrant 1 is the upper right-hand corner of the graph. If I want to graph these things, I need to go ahead and isolate for y. So in this first one, I'll call this the red one. We're going to add the x over, and you'll get something like that. Okay, now in the second one, we'll do that one as the blue one. We're going to have to subtract the x over. So I will have this. And then in the third one, we'll do the green one. That one's going to take a little bit more work. I'm going to have to subtract the 2x over, and then I'm going to have to divide by 5. And it will look something like that. Now, you'll notice that in that blue one, I have to start at 27. So I think what I'm going to do is I'm going to go by 2s on this graph. Okay, so let's go ahead and let's just start with that blue one. So if I'm going to go up to 27, I'm going to go by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and then halfway through will be 27. Okay, and then I'm supposed to go, let's see here, I'm supposed to go down 1 over 1 all the way through. Okay, so if I go down 1 over 1, I'm going to be right there. Notice these are all going to be in betweens because I started in between. Down 1, right 1, all the way through. And this is going to be a solid line. So I'll put that through those. And I really, if you guys have a straight edge to use here, I would highly recommend using a straight edge. Okay. in order to do this. Okay, and this one will be shaded below. Because it was a less than symbol. So there we go. All right, let's go back up and do that red one. Looks like I'm starting at 11. So 2, 4, 6, 8, 10. Oh, excuse me. 2, 4, 6, 8, 10. And halfway through makes 11. And this time we're going up one, right one. These should all be in-betweeners. And you'll notice that that one crosses right at that same point as the other one. And this one is also below. So we'll shade this below. Below this line would be down here. Okay. And then we have that green one. We start at 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. And we're going to go down 2, right 5. Now remember, we went by 2s here, folks. So if I'm going to go down 2, that's really just going down 1. And then over 5 is going to be 2.5 boxes. So it looks like it's going to be right on that line there. Down 2, over 5. So right there. Down 2, over 5 is right there. Okay, so you have to make sure if you go by 2s that you're taking care of everything. Let's see here. This graph was supposed to be shaded below. So if I shade below this, hopefully you see where that overlap is. The overlap is going to be this right here. All of that is my overlap. So what are my corners? Well, down here, I obviously have 0, 0. Okay, let's see here. Right here, we know what this point was. That was at 11 we started at, so 0, 11. We have this guy over here. Looks like it's right between those two, so let's count here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, and half of that will make 27, comma 0. Okay, then we have, let's see here. Looks like we're crossing right there. Now, that looks like it's in between those two. Okay, and that is the green line and the blue line. Okay, so if I want to be certain what that point is, I'm going to set the green line and the blue line equal to each other, and I'm going to solve it. Okay, so in order to do that, I would add this 1 over. So 1 plus negative 2/5 will be 3/5. Then I'll subtract the 18, and that will give me a 9. Then I'll divide by that 3/5, and 9 divided by 3/5 gives me 15. Now that's the x value, 15. Now to find the y value, I'm going to take this 15 and I'm going to plug it back into either the blue graph or the green graph. Now the blue graph looks like it would be much easier, okay, because that would just be negative 15 plus 27 if I put it right in here in that blue graph, okay, and that will give me a 12 for my y. Okay, then we have, let's see, we have this point right here where it looks like the red line and the green line cross. So we're going to do the same thing. I'm going to take the red line and set it equal to the green line. Okay, because I'm trying to figure out where they are crossing. So in order to solve this, I'll add that 2/5 over. So this will be 1 and 2/5 x. Then I'll subtract that 11 over, which will give me 7. Okay, then I'll divide by that 1 and 2/5, and that'll give me an x of 5. So this point up here has a x value of 5. Now to find my y value, I'm just going to plug it back in to either the red line or the green line. Well, I think the red line would be easiest to put it in right there. So that would be 5 plus 11, which gives me 16 for that point. Okay, so now I have my 5 critical points, and I'm going to plug them all in to my objective function back here at the top, the 4x plus 6y. So here we go. For 0, 0, if I plug in 0, 0, 4 times 0 plus 6 times 0, I get 0. Okay, let's do 0, 11. So that would be 4 times 0 plus 6 times 11, and that would give me 66. Okay, let's do 27, 0. So that would be 4 times 27 plus 6 times 0, which gives me 108. And again, this is all done in your calculator. Let's do 15, 12. So that's 4 times 15 plus 6 times 12, and that gives me 132. And finally, we had 5, 16. Okay, so that's 4 times 5 plus 6 times 16 gives me 116. So now looking at these numbers, it looks like 0 is my min and 132 is my max. Okay, now yes, folks, I understand this is quite a bit of work, but it's all work that you know how to do. You know how to graph inequalities. You know how to solve inequalities by setting them equal. Okay, we're just putting lots of stuff you've already learned together. All right, let's flip over to the back and try another one. Notice again, it says we are in quadrant 1. Okay, and I got lots of them to graph here. Let's start at the top here. I'm going to go ahead and do this top one in blue. So we'll subtract the 2x over, then divide by 3, and I get something like that. Okay, let's do the second one, and I'll do that one in red. So we're going to subtract the 3x over. Then we're going to divide by -2. And when you divide by a negative, we got to flip that symbol. And it will look like that. Notice that's a 7.5. Oh, you know what? I need to fix something here for us, folks. Let's get rid of that, please. Erase that. This equation should not have a 2 in front of there. It should just be -y, which is going to make our life a lot easier. All right, so let's go back to that. So now I'm going to subtract the 3x over, which gives me -y is less than or equal to -3x plus 15. Divide by -1, so I'm going to flip that symbol over, and that gives me now a positive 3x minus 15. All right, let's go down to the third one. I'll do that one in green. We just have to add the x over in that third inequality. And then the fourth inequality, I need to subtract the 2x over. I'll do this one in black. So that'll be 5y is less than or equal to -2x plus 27. Divide by the 5, and I get -2/5 x. And then 27 divided by 5 is going to be 5.4. All right, so here we go here. Let's start with that top one, the blue one. I'm going to start at 2, and I'm going to go down 2, right 3. So very sweet and to the point there. Solid line, looks like that. That one we wanted to shade above. So that is going to be all of this area above. Okay, let's go ahead and do the red one. We're going to start at -15. Now that's a problem, folks, because I can't start at -15. All right, so I'm going to have to do this a different way. I'm not going to be able to use y equals mx plus b. Well, I can find the x-intercept and go from there, because then it'll give me a point on the x-axis. So if I take a look at my original question right here, for every x-intercept, that means the y is 0, which means this part right here will be 0. If that is 0, then what is x? Well, you divide by 3, and the x would have to be 5, which means I'm going to start at 5, 0 for this graph. 1, 2, 3, 4, 5, 0. And then we can use our slope of 3. We're going to go up 3, right 1. And then this line will be solid, and we will be shading above this line. Okay, above this line would be this way. All right, let's go to the green line. We'll start that at 4. 1, 2, 3, 4. And we will go up 1, right 1. Looks like that. This one's going to be solid. And we're shading below. So below would be down here. So you can kind of see where they're overlapping. Right now it's that kind of triangle-ish shape in the middle. And then we have the black line here. We're going to start at 5.4. So 1, 2, 3, 4, 5.4 would be maybe there. And we are going to go down 2 to the right 5. So remember, this is in between, so all of my points will be in between. Down 2 to the right 5. 1, 2, 3, 4, 5. Down 2. 1, 2, 3, 4, 5. Okay, and this one was also shaded below. Got a gray color in here. Let's see about that one. So it looks like my overlapping shaded area is going to be this shape right in here. Okay, so what are my corners? I've got this one, which is 0, 2. I've got this one, which is 3, 0. I've got this one, which is 5, 0. That's a nice point. That is 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, we've got, oh, that's a nice point up here too. That is 1, 1, 2, 3, 1, 1, 2, 3, 4, 5, 6. Or 1, 5. 1, 2, 3, 4, 5, excuse me, 1, 5. Make sure you count carefully. And then we have this corner right here, which is 0, 4. All right, so we got lots of points, but notice these are all nice points, so I don't need to do any of that business of setting them equal to each other to find where they cross. All right, we're just going to plug these into our objective function now. So 0, 4, this will be 5 times 0 plus 7 times 4, which will be 28. For 3, 0, that will be 5 times 3 plus 7 times 0, which is 15. 5, 0 would be 5 times 5 plus 7 times 0, which is 25. Let's see here. 6, 3 will be 5 times 6 plus 7 times 3, which is 51. And 1, 5 will be 5 times 1 plus 7 times 5, which will be 40. Did I get them all? 1, 2, 3, 4. I'm missing one. Which one did I miss here? Looks like 0, 2, which should give me 14. Okay, so my min is that 14. And my max, it looks like, is this 51 up here. Okay. Moving along, let's do one more. Notice this time, this is the constraint I give you, which we talked about how that is just quadrant 1. If the x's are greater than 0, that means they're positive. If the y's are greater than 0, that means they're also positive. And quadrant 1 is the only place that that happens. Now my first line is y is less than or equal to 4. So I'm going to go to where y is 4, which is right here. And there's no x's, so it can't cross the x, which means this thing is going to be horizontal. Okay, and we are shaded below this line. Okay, my next line says x is less than or equal to 5. So we're going to go to where x is 5. And it doesn't have a y, so it can't cross the y. So this is going to be a vertical line. And that's solid again. And this should be to the left because that says less than. So far we've got that rectangle that's overlapped. And finally, I got to subtract my x over here, which looks like that. I'm going to start at 6. 1, 2, 3, 4, 5, 6. And I'm going to go down 1, right 1. And this will be a solid line. And we are shaded below this. So it looks like the overlap of all of that is this trapezoid thing. It looks just like that. Okay, so I have 0, 0. I have this guy right here. Notice it doesn't go all the way to that green one, which is 5, 0. I've got this guy up here, which is 5, 1. This guy over here, which is 2, 4, it looks like. And this one on the y-axis, which is 0, 4. All right, so let's plug them all into my objective function. Well, 0, 0 will just give me 0. 5, 0, when I plug that in, should give me 10. 5, 1, when I plug it in, should give me 12. 2, 4, also going to give me 12. And 0, 4, should give me 8. So it looks like my min is this. Looks like both of these are the max. They're both 12. Now I want you to notice what that is over here, folks. That is this point right here and this point right here. Do you see how they are both on the same line? That means that any point on this line right here is also the max. Okay, now I just want to explain that to you. And obviously your answer the way it's written here is going to be just fine. Okay, but I want to explain, because those 2 points are on the same line, they have the same max, which is 12. Any point on that line also will have a max of 12. All right, so you will need to grab some graph paper for your homework. And your homework is these 4 questions here. And I will see you all on Friday. Remember, we do have a 2-hour delay on Friday. So my hope was that we go over both of these homework assignments that I will need to check in from you. Thanks. Have a great day.